In this section, we're going to look at externalities, or when market transactions affect third parties who are not involved in that trade. No one sets out to create pollution unless you're a mustache-twirling villain in a corny movie. Pollution is an unintended byproduct of various activities that we undertake. Now, if pollution only affected the person who created it, it would not be a serious problem. People would only create pollution until its marginal cost equaled its marginal benefit, and they would stop. But pollution is an example of an externality. This is a benefit or a cost that affects someone who is not directly involved in the production or the consumption of a good or service. Think of the externality like a side effect. Two people are involved in a trade, and some other third party is getting hurt or getting a benefit from it when they're not involved in that in any way. So let's look at how this happens in the production of electricity. Electricity is an incredibly important industry for a modern economy. It helps all of us not only engage in market transactions, but it helps our normal lives. It helps it be easier, helps it be much better than it would be without electricity. We wouldn't be able to take this class without electricity. So now consider the market for electricity. It consists of sellers. They're going to face increasing marginal costs in order to produce the electricity. You have the buyers. They're going to face decreasing marginal benefits of additional electricity. So the actions of these two groups, they're going to generate the market supply and demand curves for electricity. When firms produce electricity, they bear certain costs of production. Things like the building, the equipment that they use, the fuel that goes into creating the electricity, the labor to pay the workers to actually run the plant, and plenty of other things. So when firms make the decision of how much electricity to produce, they do so based on these private costs, the costs that they themselves face. But because of pollution, there's a higher total cost. There's a social cost above and beyond what they're forced to pay. And this total cost of society of a good or service, or the social cost, includes both the private cost and any external cost. So any cost on a third party, in this case pollution, is part of the social cost, but it's not being counted as part of the private cost when firms decide how much electricity to produce and to sell. Let's turn to our model of supply and demand for a market. I hope you guys aren't getting tired of this yet. So the supply curve, S1, that represents the marginal private cost that the electricity producer has to pay. These are those costs we talked about that only they have to pay. The supply curve, S2, is the marginal social cost, and that includes the cost to those who are affected by pollution. So that's the total societal cost. The optimal level of production of society is at Q efficient, and the price is at P efficient. At this point, that's where the marginal cost of society is equal to the marginal benefit to society. And again, this is where the societal supply curve crosses the demand curve, not where the private supply curve crosses the demand curve. Now, what is the effect of the private electric producers not taking into account the total social cost of producing electricity? Well, the market equilibrium that's going to occur in the real world, in practice, is going to be where the private cost, that supply curve, crosses the demand curve. So they're going to produce at Q market, and the price will be at P market. The market price will be too low. It will be lower than the societal equilibrium. And the quantity that is being sold, the Q market, is too high, or is higher than the optimal amount for society. So the additional electricity that we're producing, the difference between Q market and Q efficient, is going to exceed its benefit to society. What's going to result is deadweight loss. Deadweight loss is going to be the triangle between the two quantities, between the quantity that's actually produced, that's the efficient market level with only counting the marginal private cost, and between the quantity that's efficient, that incorporates the marginal social cost. When there is a negative externality in producing or consuming a good or service, too much of the good or service is going to be produced at the market equilibrium. The market equilibrium will have a greater level of production than will the equilibrium that takes into account the total social cost. So in this case, you could think of the supply curve shifting up by the cost of acid rain. So the cost of acid rain is is going to represent the difference between the marginal private cost and the marginal social cost at each quantity that's being produced. They use the cost of acid rain. There's plenty of other negative side effects that are a result of pollution. Maybe it's difficulty breathing, maybe it's just soot you have to clean off your house more frequently. Tons of different things that are going to be the total cost of the overproduction of, in this case, electricity. Pollution is an example of a negative externality of production. So negative externalities may also result from the consumption of a good, not just the production of a good. So for example, cigarette smoke. Cigarette smoke is an annoying externality. People don't like the smell, they get difficulty breathing. This is caused by the consumption of a good rather than the production of a good. So negative externalities can be because of the producer or because of the consumer using the product. Externalities can also be positive. It could be a good thing. So positive externalities exist when the private benefit, so the benefit received by the consumer of a good or service, is less than the social benefit, the total benefit from consuming a good or a service. That includes both the private benefit and any external benefit. So for example, college education has a positive externality. Individuals don't capture the full benefit from a college education because other people benefit from living in a society with more educated people. More educated people, a more skilled workforce can produce better goods. You have higher quality goods. There's a lot of other positive things that are associated with college education. So these spillovers, these positive spillovers, mean that individuals, the consumers themselves, the people getting educated, end up doing less education than is socially optimal because they don't get to capture the full benefit. Let's use an example, and let's explore more deeply the positive externality associated with college education. So the marginal social benefit from a college education is going to be greater than the marginal private benefit to college students. So the marginal private benefit is going to be represented on the figure on the right by D1, that demand curve. The marginal social benefit is represented by D2, and this is going to be higher than the initial demand curve for just the private benefit because this positive externality exists. And that positive externality is a difference between those two curves, the two demand curves. The market equilibrium, when people are just taking into account their own costs and benefits from college education, is going to be at the price P market and the quantity Q market. And that's only when individuals are taking into account the private costs and benefits that they're facing. Now, if people consumed a college education, if they got educated at the demand curve that took into account the marginal social benefits, so the benefit to all of society from the college education, there would be a higher price for college, but there would be a greater amount of people going to college. There would be more consumers in this socially efficient market. So in essence, when there's a positive externality, there is too low of consumption for a good or service. And when there are too little of a good or service being produced and being consumed at equilibrium, at the market equilibrium, what we're going to experience, again, is a dead weight loss. And this dead weight loss is going to be the area, that little triangle that's shaded yellow in your diagram. So it's going to be the difference between the quantity that's being provided at the efficient level, so it's taking into all the social benefits, taking into account the externality, and the level that's being produced in the market that only takes into account the private costs and benefits. So if individuals in the market were able to take into account, they're able to capture that social benefit, they would consume more college, and colleges would produce, more opportunity for education, and we would increase the quantity of college educations that are being consumed. When externalities are present, whether it's a positive externality or negative externality, the market equilibrium will not result in the efficient quantity being produced. When there are negative externalities, we're going to see overproduction. So we'll see too much of a good being produced because they're not taking into account the total social costs. And on the other hand, when there's positive externalities present, we'll see underproduction. So too few people will be producing and consuming that good than they would if they did take into account the total social benefits. In both cases, there's going to be what we call a dead weight loss. Now, this dead weight loss, this market equilibrium not leading us to the efficient level of production. This is an example of a market failure. Again, this is a situation in which the market fails to produce the efficient level of output. Now, the larger the externality is, the greater is likely to be the size of the dead weight loss. So the extent of the market failure is going to be larger, the larger the externality is. In the next section, we're going to explore some solutions, some potential ways to try to bring the social demand curve and the social supply curve in line with the private demand curve and the private supply curve.